Let's look at the basic rules for finding derivatives. In this section, we will learn how to take the derivative of a constant, learn how to take the derivative of a polynomial, learn the power rule for derivatives, learn how to take the derivative of an exponential function, and learn basic trigonometric derivative rules. As you study the rules in this tutorial, remember that the derivative is defined to be the slope of the tangent line. Rule number 1, the constant rule. Let f of x equal k, where k is a constant. Then the derivative f prime of x is equal to 0. Recall that f of x equal k is a constant function whose graph is a horizontal line. Any tangent line would also be horizontal, which would have the slope of 0. Rule number 2, derivative of k times x. Let f of x equals kx, where k is a constant. Then the derivative f prime of x is equal to k. Recall that f of x equals kx is a linear function whose slope is k. Any tangent line would also have to have a slope of k. Example. Example number 1. Let f of x equal -4. This is a constant function, so the derivative is f prime of x equal to 0. Example number 2. Let f of x equal 8x. This is a linear function, so the derivative is f prime of x, which equals 8. Rule number 3, the power rule. Let f of x equal x raised to the nth power, where n is a real number. Then the derivative f prime of x is found by taking n times x and then using the exponent n minus 1. Example number 1. Let f of x equal x squared. The derivative is f prime of x, which is equal to 2 times x raised to the 2 minus 1 power, which simply becomes 2x. Example number 2. Let f of x equal 1 divided by x. This can be rewritten as x raised to the -1 power. Applying the power rule to this gives us the derivative f prime of x equal to -1 times x raised to the -1 minus 1 power, which becomes the exponent -2. Let's look at example 3 here, where f of x equals x raised to the 1,000th power. Applying the power rule gives us the derivative f prime of x equal to 1,000 times x raised to the 999th power. Example 4. Let f of x equal the square root of x. We can write the square root of x as x to the 1/2 power. Applying the power rule gives us the derivative f prime of x equal to 1/2 times x to the -1/2 power. If we take that one more step, x to the -1/2 moves to the denominator of the fraction and becomes 1 divided by 2x to the 1/2 power. Rule number 4, the constant multiple rule. Let f of x equal k times g of x, where k is a real number. Then f prime of x will equal k times the derivative of g of x. Let's say we have f of x equal 17x to the 5th. Then the derivative f prime of x would equal 17 times x to the 5th's derivative. The derivative of x to the 5th is 5x to the 4th. So ultimately our answer becomes f prime of x equals 85x to the fourth. The derivative of a polynomial. When you're trying to find the derivative of a polynomial, take the derivative of each term of the polynomial. As an example, let f of x equal 3x squared plus 8x minus 9. In order to find the derivative f prime of x, we will take the derivative of 3x squared, which becomes 3 times 2x, plus the derivative of 8x, which becomes 8, plus the derivative of 9, which is 0. The derivative of the polynomial becomes 6x plus 8. Example 2. Let f of x equal 4 divided by x cubed minus the cubed root of x squared. In this case, we can rewrite it as 4x to the negative 3 minus x to the 2/3. We now take the derivative of each individual piece, and we get 4 times negative 3x to the negative 4 minus 2/3 times x to the negative 1/3. This gets rewritten as negative 12x to the negative 4 minus 2/3 x to the negative 1/3 power, which becomes negative 12 divided by x to the fourth minus 2 divided by 3 cube roots of x. Time to check yourself. Answer the following questions true or false. Question 1. The derivative of f of x equals 5x squared is 10x. That is true. Question number 2. The derivative of f of x equals 17x is 0. That is false. F of x equals 17x is a linear function, so its derivative would be 17, the same as the slope. Question 3. If the derivative exists at a point, then the function is continuous at that point. This is true. Rule 5, the natural exponential rule. Let f of x equal the function e to the x. Then f prime of x equals e to the x. The exponential function has the property that it is its own derivative. Example, let f of x equal negative 5 e to the x. The derivative f prime of x is going to equal negative 5 e to the x. Rule number 6. The derivative rules for sine of x and cosine of x. Let f of x equal sine x. Then the derivative of f of x would equal the cosine of x. Let f of x equal the cosine of x. Then the derivative of that f of x equals negative sine of x. Let's say we're finding the derivative of f of x equals negative 3 sine of x plus 5 cosine of x. The derivative is going to be the derivative of the two individual pieces. The derivative of negative 3 sine of x equals negative 3 cosine of x, while the derivative of a positive 5 cosine of x becomes negative 5 sine of x. This makes the derivative f prime of x equal to negative 3 cosine of x minus 5 sine of x. Here are the derivatives for other trigonometric functions. Since all other trigonometric functions can be written in terms of sine of x and cosine of x, their derivatives are easy to derive. Their derivatives are summarized as follows. The derivative of f of x equals the tangent of x is f prime of x equals secant squared of x. The derivative of f of x equals the cosecant of x is f prime of x equals negative cosecant of x cotangent of x. The derivative of f of x equals the secant of x is f prime of x equals secant of x times tangent of x. The derivative of f of x equals the cotangent of x is f prime of x equals negative cosecant squared of x.